Hi guys. So this is my quick video. I'm going to talk kind of fast, so feel free to pause and rewind if you miss anything. This is note 7.6, molecular geometry. It's really the next thing after Lewis dot structures, covalent Lewis dot structures. So I'm just going to go through the PowerPoint and say what's important here. So this is what covalent bonds are. It's overlap of atomic orbitals. Sorry that I bumped that. Attractions and repulsions between electrons and protons. So there are two things. There's molecular orbitals, and then we have bonding orbitals. I don't know if you can see this mouse, but we'll see. All right. We also talked about sigma and pi. So sigma is a single bond, and then anything after the first single bond becomes a pi bond, which is just an overlap. So if you've got just a single bond, then that's a sigma. If you've got a double, then you have a sigma and then a pi. If you have a triple, you have a sigma and then a pi and then another pi. Okay. Why is the shape important? It helps us determine properties, uses, smell, taste, proper drug targeting. And we call this VSEPR because it's valence shell electron pair repulsion theory, which is fun to say, but it just means electrons are repelling each other, and then it changes the shape. So we can predict these shapes based on the numbers of areas of electron domains. And there's two types of so electron domains is the umbrella term. And then you have bonding areas and you have non-bonding areas. And non-bonding areas are the lone pairs. So, as in a previous video, and maybe someday I'll be able to go in and make a better one, but anyway, it's not bad, okay? You make your Lewis dot structure and make sure you do that properly, because if you don't, and you don't know that there's a lone pair on the central atom, then your shape is going to be wrong. So you need to have a proper Lewis dot structure. Then you count the number of total electron domains around the central atom. I don't care if there are lone pairs around anything on the outside. I only care about the central atom. Any single, double, or triple bonds counts as one single domain. It's just one area coming off of that center atom. And then each lone pair also counts as one domain. The shape then is based on the number of non-bonding, bonding and non-bonding domains around the central atom only. Okay, so first we have here for water, we've got two lone pairs, so two non-bonding domains, and we have two bonding domains. So in total, we have 4 electron domains, 1, 2, 3, and 4. And of those, 2 of those are non-bonding and 2 of those are bonding, okay? And so this would be called, this is called a bent structure, and I'm pretty sure that's later on. So for this, how many domains are on the central atom? So for carbon, we've got one thing here, one thing here, one thing here, one thing here. That's 4 domains. For nitrogen, 1 here, 1 here. This double bond counts as one thing coming off. Another thing, so we have 3 domains on the nitrogen. And then for carbon here, we've got, so this carbon has 1 lone pair and 1 bonding domain coming off of it. And the same thing for this oxygen, 1 lone pair coming off and 1 bonding domain. Okay. All right, so the first shape we have is linear, just means in a line, in a straight line. There is no lone pairs around the central atom at all. Okay. The next we have is trigonal planar. This isn't working. I did something. It's thinking. Trigonal planar is you have 3 things in a single plane, okay? You have no lone pairs on it. So it has 3 things with no lone pairs. Great. Next, we have a bent. So this has 2 bonding domains and 1 non-bonding domain, okay? You have 2 types of bent. It either has 2 lone pairs coming off of it or just 1 lone pair. It's still called bent. Okay. I don't know if it's going to do that every time. Tetrahedral. It has 4 bonding domains coming around it. That's it. Okay. trigonal pyramidal. Okay, so the difference between trigonal pyramidal and trigonal planar is trigonal pyramidal has a lone pair coming off of the central atom. That's it. That's the only difference. Again, this is the last bent one. This one happens to have 2 lone pairs coming off of it with 2 bonding domains. And those are all the 4 shapes. So this is a Lewis dot structure. Again, we do not care if there are not lone pairs on any of the outside. We only care what is on the central atom. That's it, the end. So this has 2 electron domains. Of those, there is 2 bonding pairs, one here, and there is no lone pairs on the carbon. So this shape is linear, looks like that. And for the geometric arrangement, I can't go back. Let me see, maybe I can. Geometric arrangement, you just have 2 things coming off the central atom in a straight line, okay? All right, for this one, okay, we have trigonal planar. Now remember, boron is one of those fun ones that only can form 3 bonds or only wants access to 6 electrons, 2, 4, 6 right there. So this has 3 bonding pairs and no lone pairs, so 3 electron domains. Of those, there's 3 bonding pairs and 0 lone pairs. The molecular shape is trigonal planar because there's no lone pairs on the central atom. Looks like that. Here's the geometric arrangement. It all has to be as equally far apart. You cannot make it in a T-shape. This is for the Lewis structure only. You cannot put a T-shape for the geometric arrangement. That's incorrect. For this one has 3 total electron domains. You got 1, 2, and then a lone pair 3. So of those, we have 2 bonding pairs, and then we have 1 lone pair. And this is called a bent molecule. For the geometric arrangement, you have to put them going downwards. Well, I guess you could put them upside down if you want. And then the lone pair is up at the top or bottom, depending on what you're doing. Okay, for this one, tetrahedral, this is the Lewis structure. The geometric arrangement has to have something coming towards you and away. The towards is the darker filled in triangle. The away is the one that's kind of slash or whatever. Dotted line, if you want to call it. There's 0 lone pairs, 4 bonding pairs, tetrahedral. Again, looks like that. For this one, for the trigonal pyramidal, it has a lone pair. So this is the Lewis dot structure, and this is the geometric arrangement. This one also needs a coming towards and away with a lone pair at the top. Now you have to have them kind of going down, and then the lone pair is up at the top. For this, there's 3 bonding pairs, 1 lone pair. The molecular shape is trigonal pyramidal. Looks like that. All right, again, we have the last bent one. Okay, so this is the Lewis dot structure, but the geometric arrangement, you have to put them down like this because the electrons, the lone pairs rather, are pushing down on those 2 bonds for the hydrogens or whatever it is, and is causing them to get pushed down. So 2 bonding pairs, 2 lone pairs. This is also called bent, and it looks like that for the ball and stick, but this is the geometric arrangement that you guys need to know. Okay? Let's see. Again, this is an overview of all the different shapes: linear, trigonal planar, bent, tetrahedral, trigonal pyramidal, and again, bent, but this time with 2 lone pairs. Okay, so that was it for this lesson. Let me know if you guys have any further questions. Maybe I went too fast. Feel free to go back around and watch it again in slow motion if that's a thing, and submit any questions you have. I'd be happy, still updating videos. So see you next time.